Euclid's algorithm. Let us see about Euclid's algorithm. How the Euclid's algorithm is useful in evaluating the GCD of two given numbers. As per Euclid's algorithm, when you want to find GCD of A, comma B, GCD of A, comma B is given. If A equal to 0, then GCD of A, comma B can be directly written as B. Because when A equal to 0, I substitute GCD of A, comma B by 0, comma B. We already discussed that 0, comma GCD of 0, comma any number is that number. So GCD of 0, comma B is B. Similarly, when B becomes 0, GCD of A, comma B becomes A. So whenever I'm having GCD of A, comma 0, we can directly conclude the GCD of A is A, comma 0 is A. And then we have to write the A in quotient remainder form. That is A equal to B into some quotient plus remainder. You're going to split out the numbers and then find the GCD of B, comma R using Euclid's algorithm because GCD of A, comma B equals GCD of B, comma R. This is the procedure. The Euclid's algorithm states that for any non-negative integer A and any positive integer B, GCD of A, comma B can be given as GCD of B, comma A mod B. So this is given as remainder. GCD of A, comma B, comma GCD of B, comma A mod B. Let us see an example. Let us take GCD of 18, comma 12. So here I can write this is the A, this is the B. A now A equal to 0. No, B is also not equal to 0. Then we are going for the third step that GCD of A, comma B is given as GCD of B, comma remainder A mod B. Am I right? That is given as A mod B. So GCD of 18, comma 12 is GCD of 12, comma 18 mod 12. I am simplifying this. GCD of 12, comma 18 mod 12 is remainder 6. Then GCD of 6, comma again B here 6 becomes here and again 12 mod 6. I'm having that this becomes A, this becomes A, so 12 mod 6. So here I'm having GCD of 6, comma 0. When we already discussed that if I'm having one number is 0, the other number becomes the GCD. So GCD of 6, comma 0 is 6. So now GCD of 18, comma 12 is 6. And if I'm having a number like this, the stepwise we are going for recursively, GCD of 270, 190. As per our Euclid's algorithm, we need for A, B, for two numbers A, B, I have to split up into such that A can be written as in terms of B. What are the quotient? Some quotient plus the leftover remainder. That is what I have written in the first step. In the next iteration, what will happen? This R1 will becomes the B2 and B1 becomes the A2. The next step, the previous remainder becomes the current B and previous B becomes the current A. The step will keep on going. Let us see an example using GCD of 270, 192. So I am going to take here A equal to 270, B equal to 192. Okay. So here I can write that 270 equals, because I write in the form of A equals B into some quotient plus some leftover remainder. So now 270 and B is 192. So 192 1 into 1 is 192. 192 becomes 380 plus. So it cannot take it. So 192 into 1 plus what are the remainder is 78. 270 minus 182, 78. The next step, I am bringing the 192 here, 78 here. So I'll have 192. I'll write 192 in terms of 78. So now 78 into 1, 78, 78 into 2, I'll have some 140, 156, right? So 78 into 2, I can write 78 into 2, so 140, 156. The remainder is plus 36. So I'm decomposing with the remainder. Now again 78 will come here and I'll have 36. 78 equal to 36 into 2. 36 into 2, 72. The leftover is 78 minus 72, 6. So here when I take here, 36 equals, the 6 comes here. So 6, I can write, or I can write 6 can be written as 6 into 6 plus 0. What will happen in the next step? I'm having the 6 will come here and 0 will come here. Now what happens? A is 6 and B is 0. I cannot proceed further because I'm having a 0 here. So when I have GCD of A comma B, what will happen? When one number is 0, other number becomes the GCD. So answer is 6. So I have evaluated and find out that GCD of 270, 192 is 6. Let us take another example. GCD of 15, 8. I can write 15 equals 8 into 1. Again, 8 ones are 8. So 15 minus 8, 7. Now in the next step, 8 comes here, 7 comes here. So 8 equal to 7 into 1 plus 1. So here I am having that 7 equals, I am right, 1 into 1 comes here. So 1 into 7 plus 0. So here it comes 1 and 0. So now here again A becomes 1 and B becomes 0. So the GCD becomes 1. So GCD of 15, 8 is 1. So when the GCD of 15, 8 is 1, 15 and 18 becomes co-prime numbers.